Hi, everybody. This is Mr. Folly, and welcome to Podcast 6.1. We're going to bust out a little calculator fun and learn why chemistry is a physical science, meaning we measure more of the stuff instead of think about it. And we're going to talk about the mole, which is a unit that tells you the amount. It's basically a count of particles. So let's get started. So all of these particles are small, really small. How small is a cell? Itty bitty. See this? This guy right here looks like he's small, but I'm sorry. Here's a cell. So if I'm looking at a cell, 7e15 atoms in a cell. That means 7 with 15 zeros. 2, 3, 4, 5, 6, 7, 8, 9, 10. That's a lot of them. 6.6 times 10 to the 20th formula units in a grain of salt. That means this thing right here is 6 with 19 zeros. Wow, that's so many, I don't even want to write them all. Okay? So what happens is when these things are so small, we need to be able to group them like grains. Counting grains would be better than counting this many particles of how many NaCl's there are, or this many this many cells when I want to look at a certain culture. In Indiana, I buy a ream of paper, a gross of bottle rockets, yeehaw, and a pallet of Bondo. Bondo is like duct tape that holds your car together, for those of you who don't live the wonderful hillbilly lifestyle I do. So a ream of paper is 500 sheets of paper. A gross of bottle rockets is 144. And a pallet of Bondo, if you go to Costco, you see the pallets, so that one was just kind of fun to be a little more hillbilly. But why are these numbers of 500 and 144, why are they such large numbered groups? Now, this is a Mr. Follyism. I made this up, okay? I think it's about a handful, okay? A ream of paper fits in your hand. A gross of bottle rockets fits in your hands, okay? Why such large number of groups? To get a handful, or because they are small. We use a mole in chemistry, and the number for a mole in chemistry is 6.02 E23. One thing I want to do really quickly is show you how to get that E on your calculator. So if I want to put this in, I would type 6.02, and then I hit the second button, and then there's a comma. Second comma, 23, and that will look like 6.02 E23, and that does it for you. Okay. And then why do we use a number that's so big? Because the particles are so small, and this gives us about a handful. A mole of water is about a handful of water. A mole of carbon is about a handful of carbon. So how many are in 1 mole of water? 6.02 E23 molecules. Huh. Helium, 6.02 E23 atoms. Notice how we changed what they are a little bit because helium's an atom and not a molecule. Calcium fluoride, 6.02 E23. Now, if it's an ionic compound, remember they're a network, so they are a formula unit. You don't really need to know the difference between these, but I like to be chemistrically correct. How many calciums are in calcium fluoride? I didn't want to do that one, so I'll skip it. How many times Matt thinks blue is a French color? Well, that's at least twice. Mass is measured in grams. I think you know that. We measure mass in grams. And we have a periodic table that looks a little something like this. Okay? So if I want to know the mass of a mole, so I go to the periodic table to find my masses. So little mass measured in grams. Little g stands for grams, and little g stands for go to the periodic table. So if I have NO, I want to use the masses. N, we're always going to use 2 decimal places. 2 decimals from periodic table. So nitrogen is 14.01. Yeah. And oxygen is 16.00. 30.01 grams. Oh, hey, how about that? Al2C2O4 taken 3 times. Ooh. Okay, so you have a periodic table. I surely hope. So aluminum is 26.98 times 2. Okay. Carbon, now look in the periodic table. Hey, it's right here. Is 12.01 But do you see how I have this? I have 2 carbons times 3. Ah, get back here. Ah, get back here. Okay. Come on, times 6. And this is 72.06. This is 53.96. And then my oxygens, I have 4 times 3. So oxygen is 16.00. 4 times 3 is 12. And that is 192. So my total mass is going to be the sum of all of these, right? So I add up my aluminums, I add up my carbons, I add up my oxygens. So 192 plus 72.06 plus 53.96 is 318.02. And don't forget units of grams. Okay. Factor label, I sure hope those things go away. Convert 12 grams of CO2 into moles. Okay. So here's what I'm going to do now. I'm going to start, we did this way back when, 12.5 grams of CO2. And what I'm going to do is I am going to get rid of my units. Okay. Now when I do factor label, this is going to equal 1. So if I have grams of CO2, I hate you grams of CO2, and I want to go into moles. So remember how we just found out of CO2? Remember we just found out that 1 mole equals, little g stands for grams, and little g stands for go to the periodic table. So carbon is 12.01, and oxygen is 16.00 times 2. So when I add all that up, I get 44.01. Remember, multiply the top. Divide bottom. Multiplying by 1, I'm not going to insult your intelligence by even insinuating putting that in my calculator. But 12.5 grams divided by 44.01 is 0.284 moles. Now notice, grams of carbon dioxide cancel, moles of CO2 remain. Okay. Abbreviation for moles, M-O-L-E, is M-O-L. Woo! So M-O-L-E, shortcut, M-O-L. How wonderful is that? I guess it's better than a stick in the eye. Convert 19.9 moles of oxygen into grams. So I'm going to write down my given, 19.9 moles. Now, this is tricky. Oxygen is O2. It's diatomic. Oh, did I get you? Ah, first trick of the year. So now I want to cancel moles, so I hate you moles. I'll put you on the bottom. 1 moles of O2. I killed you moles. Ah! Moles of O2. And then I'm going to go into grams of O2. Now, little g stands for grams, and little g stands for go to the periodic table. And notice right here, I have 2 oxygens again. 16 times 2 is 32. So I'm going to take 19.9 times 32. And I'm going to get a big old number of 636.8. Notice I've killed my grams by canceling. Grams of O2. Moles are also found in solutions. Now, a solution is like a thing of water with stuff in it, right? Not like answers to questions, but solutions like that. The formula for moles is molarity equals moles over liters. I guess I didn't say that. That was the moles. That's moles. And then moles is moles of, I'm going to call it powder for now, but it's really the solute. And it doesn't have to be a powder. Put a little star because I'm lying to you, but it could be a gas or something. But moles of powder or moles of your solute in liters of solution. Molarity practice. Woohoo! 10 grams of NaCl are placed in 250 liters of solution. What is the molarity? Now notice molarity. Anytime I see molarity, molarity equals moles over liters. I've got liters. Check, baby, check, baby. 1, 2, 3, 4. Moles? Yeah, give me grams. Oh, I have to change grams to moles. I do that by factor label. I have grams of NaCl, and I want to go into moles of NaCl. What I want goes on top, and I want to kill the moles of NaCl. Okay? 1 mole equals, go to the periodic table, Sodium is 22.98. Chlorine is 35. Whoops, I put a C. Chlorine is 35.45. So 22.98 plus 35.45 is 58.43. And that will give me 10 divided by, that answer is 0.171 moles. Okay, so now what I'm going to do, if I'm finding the molarities, I now have moles. 0.171 over 2.50 equals, that's not right, 0.171 divided by 2.5 is 0.0684 moles. Oh, sorry, molar. And capital M is molar. It has to look like capital M, and it's said molar, like the teeth that people that live in your neighborhood have. Okay? Hope that makes sense. The other type of thing we ask is how many grams of K2O are needed to make, I made a boo-boo. We'll call it 150 milliliters of 1.22 molar solution. Oh my goodness. I'm going to do the work up here. As you scramble and pause and write down the answer to that one. Okay, Okay, so I'm doing how many grams needed to make 150 milliliters. Okay, so what I'm going to do first is write my molarity equation. Molarity equals moles over liters. And notice I have a molarity, but I don't have liters. Remember, milliliters to liters, I divide by 1,000, which means move decimal 3 places. Okay, so if I have 1.22 equals moles over 0.150. So then I'm going to cross multiply, and moles equal 1.22 times 0.150. I get back here. Clear 1.22 times 0.15 is 0.183 moles, but the question says how many grams? Oh, poopsties. So now I need to convert my moles into grams. 0.183 moles of K2O times, I hate you moles, I'm going to put the moles on the bottom to kill them. I'm going to go into grams of K2O, and 1 is going to always go with moles, and K, I go to the periodic table. K is, I hope, 39.10 equals K, and 16 equals O. Now if I have 39.10, I have 2 times that. So 2 times 39.10 equals plus 16 is 94.2. Remember, I'm getting this from the periodic table. So 0.183 times 94.2 is everybody's favorite answer of 17.24. 17.2 grams of K2O. Moles of gas can also be calculated. Gas particles are so small they don't matter. Okay, so what that means is they're all kind of the same. So how many ants fit in a car? You don't say, how big are the ants? Well, it doesn't really matter. There's a whole bunch of ants that fit in any of them. If I said how many people, how big matters. But ants, it doesn't really matter. Okay? So that part, you don't need to write that down. That's kind of the rationale because people freak out about this. But 22.4 liters of any gas is 1 mole. Any gas. Isn't that weird? 22.4 liters of any gas equals 1 mole. 22.4 liters of any gas equals 1 mole. Any. What if it's helium? 22.4 liters. What if it's hydrogen? 22.4 liters. What if it's CO2? 22.4 liters. Okay? So how many liters is 25 grams of oxygen? So I'm going to do 25 grams of oxygen, And here's the thing, we're always going to go through moles. Moles, 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 moles. I don't know how many grams are in a liter. That I don't know. But I know how many moles are in a liter. So I'm going to go from grams. I hate you grams. I'm good at canceling this and go through moles. So 1 mole, I go to the periodic table, 32 grams. Now I'm in moles, but I want liters. So moles of O2, I'm going to convert it now into liters of O2. Anytime I have liters, it's 22.4 equals 1 mole. So notice right here, oh, get back here. 22.4 liters is 1 mole. Okay, so again, when I want to do this, I can always transfer things into moles. I know 32 grams equals 1 mole because the periodic table tells me so. I know 22.4 liters equals 1 mole. I just learned that 2 dots ago. Remember, divide by the bottom, multiply by the top. So I'm going to have 25 divided by 32 times 22.4. I have 17.5 watts. Notice grams of oxygen cancel, moles of oxygen cancel, liters of oxygen remain. This is going to seem pretty crazy with all the unit things that we're canceling through, but write this down, take a look at it, and we're going to spend a lot more time with it tomorrow. Okay? So, review. Woohoo! Moles are a count, like a dozen. Grams to moles, use the periodic table. Liters to moles, use 22.4. Particles to moles, 6.02 times 10 to the 23rd. And that is it. So I will say Old Lang Syne. I hope that does not mean something obscene. I sure hope it doesn't, because I play it on TV. And I will say toodles. Oh, and molarity is moles over liters. Ah, where's my end?